Okay, so if you missed it on the recording, I'm just telling you that the method that I prefer for all equations is point slope form. Learn it, know it, live it. All right, we're moving on. Okay, so application. This is actually a problem out of your book. We won't be doing too many problems out of the book. The only reason this is in the slides is because when we first wrote our first lesson, it was when we were sitting with the Cengage people in this little demo, and she said, all right, now use the new software to write a lesson. So we all sat and wrote a lesson, and so we were pulling from Cengage resources. But after like day 2, I stopped doing that and just started going back and doing all my own examples again. But anyway, so this is a Cengage example. A tank holds 1,000 gallons of water, which drains from the bottom of the tank in half an hour. The values in the table show the volume of the water remaining in the tank in gallons after t minutes. If P is the point at 15 to 50, on the graph of V, find the slopes of the secant lines PQ if Q is at t equals 5, 10, 20, 25, and 30. We are not going to do 5, 10. I know you can calculate slope. Let's just do one of them. So let's just do at t equals 10. So we're going to call that Q. So I want you to take a minute and just find the slope for the line that passes through P and Q. Find the slope of that line. For the line that passes through P and Q, you are going to have to figure out what is X and what is Y. What is your input and what is your output? So I'll give you 30 seconds of silence. I'm going to pause this. 30 seconds of silence, and then I want you to talk about it. Casper!
Hey.
Hey, how's it going?
Fabulous.
Fabulous. Great. What did your group get for the slope of the secant line?
Negative 194 over 5.
Negative 194 over 5. Negative 194 over 5. So, Casper, do you know what the units would be that go with this number? So, okay, I'm going to give you a hint. Do you want a hint? Or do you want to just see if you can figure it out? Very good. Okay, the numbers that we got on top were V values, right? So you do the units for V, which are gallons. The numbers that we used on the bottom were T values. So you do the units for T, which are minutes, right? All right, so let's think about what this means. This means that from time 10 to time 15, so from 10 minutes to 15 minutes, the tank is draining at an average rate of negative 194/5 gallons per minute. That's around negative 33, negative, I don't know what that is. 5, let's pretend it's around 200. So 38? Okay. 38.8. All right, let's just say negative 38. All right, so let's just say that the average rate is around negative 38 gallons per minute, right? So from 10 to 15, in old school think, we would say after each minute that progresses, the tank should have 38 less gallons of water in it, right? Does that kind of make sense? So that's an average rate, 38, so it's draining at a rate from between those times, average rate of 38 gallons per minute. Does that mean it really is draining at 38 gallons per minute that whole time period exactly? No. That would be if our graph of this function was a line, right? A line has what's called a constant slope. It's always the same, right? This is not a line, this is a curve. So that slope changes in that interval, but we have no other information than this to use to calculate our slopes. So this is the best we can get, right? Now, the book is going to ask you tonight, negative 38.8, there it is. Okay, the book is going to ask you tonight to estimate the slope by averaging the slopes of 2 secant lines, right? So if you want the slope at t equals 15, which 2 secant lines do you think would be the best ones to average? Right, 10 to 15 and 15 to 20, right? You take those 2 slopes, average them together, you get a pretty good approximation for the slope at 15. It's not perfect, but it's something we can go with. And that's what you're going to need to know for your homework tonight. By the way, do you all know how to average? If I gave you those two, like say the slope from 10 to 15 was negative 38.8 and the slope from 15 to 20 is negative 27.8, what would you do with those two numbers to find their average? Okay, good. All right, good. Add together, divide by 2. Now, the College Board doesn't make you do that. You can, but they don't make you. So if on the College Board, if they give you a table and say, hey, give us an approximation or an estimate for the slope at 15, for them, you can do any of the following. You can find the slope from 10 to 15 and say that's your answer. You can find the slope from 15 to 20 and say that's your answer. Or you can find the slope from 10 to 20 and say that's your answer, because it's the closest interval that has 15 in the middle, right? This is the way that I will always do it. I will always, like, if I want the slope here, I'll just go like kind of one up and one down on the table, find the slope from 10 to 20, and then say, there you go, and that'll be fine. The College Board accepts anything that's reasonable that's like near 15, right? So anything that's reasonable is fine, including taking those two slopes and averaging. They accept that too. As long as you show all your work, your setup, they're fine. But personally, the fastest and easiest one that I think is to use is to just go slope 10 to 20 and be done. So anyway, all right, moving on. Uh-oh, brain break. Suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity of the ball after 5 seconds. So you have dropped a ball off the top of this building, and after 5 seconds, you want to know how fast is it going at that moment, right? Okay, so first question we need to ask is, what is velocity, right? So I've given you, by the way, I said note the position of the ball after t seconds is s of t equals negative 4.9 t squared plus 450. That's the position of the ball, meaning the distance from the ground, essentially, right? So when t is 0 at time 0, we're 450 meters above the ground, right? Okay. All right, so that's our position function, but I didn't ask for position. I asked for velocity. So let's see here. Kirthana. Hi, Kirthana. How are you? I'm doing great. Do you have any idea what velocity is? Even in words?
It's like speed and direction.
That's beautiful. Oh my gosh, that was more than I was looking for. I was just looking for like how fast you're going, right? Okay, so speed, that tells you how fast you're going. And the direction, am I going up or am I going down? Is this ball going to go up or down? It's going down, right? Okay, so, and that's what the difference is between velocity and speed. So speed doesn't have any direction associated with it. Velocity does, which means velocity, for you physics people, velocity is a vector and speed is a scalar. Scalar, not vector. Yes, scalar. All right, good. So that's perfect. That is what velocity is. How do we calculate it?
Distance over time.
Distance over time, or in to be more accurate, it's technically not distance, it's technically displacement over time. So it's really change in position over change in time, right? So when you're falling, your distance and your displacement are the same because you're not going to change direction in the middle of the fall. But if you're moving sideways and you change direction a bunch of times, your average velocity has nothing to do with how far you traveled. It's just where you ended and where you started. How far apart are you? We'll talk more about that later. Right now, let's just know it is change in position over change in time. Change in position over change in time. All right. That velocity formula looks a lot like what have we been talking about? Slope, right? It's just a slope formula. Velocity is really just a slope of the position function. It's the slope of the position function. However, because this is involving change and this is involving change, This isn't an instantaneous velocity. This gives you average velocity. Average velocity is when you actually have a change in a position and a change in your time. So if we want the velocity at t equals 5, what do? There's no change in position, there's no change in time. What have we been doing all along?
It's like the approximation.
Exactly. We just pick a point that's close and we just do an old-fashioned slope, right? Okay, so I want you to take your calculators and I want you to calculate the velocity. You had to find your actual positions at 5.1 and 5. So you end up with, this is the book's answer. What's wrong with this answer? It should be negative, and you're absolutely right. Right? It is negative. So, and the reason it's negative is because it's traveling down, right? It's going, so. Anyway, yeah, negative 49.49 meters per second is that answer. All right, I hope you all do well on your homework tonight. If you find any problems, don't be